Hello student, welcome to my new video. In this video, I will talk about vectors. So as a 10 plus 2 student, you know the vector is very important. And those who are studying in class 11, it start with vectors actually. And vectors are very important to solve many problems involving force, electrostatic, magnetostatics, and many others problems. So it is good to have a strong and good concept over vectors. So I'm here to help you. Actually, I start with some basic idea about vectors. Then I will take some problem and which I will solve in my lecture. So this is the lecture one. So let's begin. So what is vector? So what is vector actually? So vector is basically represented by, say, this is a vector A. It is represented by a letter with an arrow. Arrow actually gives the direction. That means a vector must have some magnitude, and magnitude is written as mod of A and with some particular direction. So vector has magnitude as well as some direction. So uh, any vector can be written as A is ax y hat, ay j hat, and az k hat. So what is ijk? Ijk is the unit vector along x-axis, y-axis, and z-axis. Suppose say this is three axis, x-axis, y-axis, and z-axis, and if this is a vector A, then if you project this vector in xy plane, then you will find this is ax, okay, and this is ay, and if you project it in this plane, then this is az, okay, and along x there is a unit vector I hat, along y there is a unit vector j hat, and along g the unit vector k hat. Unit vector has magnitude 1 and they are mutually perpendicular, so they actually make the right-handed orthogonal triad. That means if you use the corkscrew rule, then if you move from x to y, it will go towards z. Okay, so simply like that. So any vector can be represented by this method, that is the component up and along three perpendicular direction. Now, what you need actually, we need to have do some addition or subtraction of vectors. Okay, so we have certain rules to for addition and subtraction of vectors. Suppose say you need to add these two vector A and vector B. Okay, so there are two laws actually. One law is called the triangle law, and another law is the law of parallelogram. Okay, so what is triangular law? The first law. Suppose A and B are represented by the corresponding sides of a triangle. Okay, then the third side will represent the resultant of two vectors, that is the addition of two vectors, and this is the direction of the resultant. Okay, so once you find the two vector which is acting at an angle theta, then the resultant of two vector is acting along this, and this is represented by r. R is the resultant, and it will be a plus of b. Okay, so addition, you can add these two vectors in a simple way. Okay, similarly you can also use this component formula. Means if you just break down B also in terms of three perpendicular direction, that is A, Bx, By, and Bz. Then you can take common I hat. Then it will become Ax plus of Bx I hat, By plus of Ay plus of By j hat, and Az plus of Bz k hat. So you can also add in this way also. Okay. Now we have another law, which is the parallelogram law. Means if you have a parallelogram and if two vectors are represented by the corresponding sides of this parallelogram, then the diagonal of this parallelogram represent the resultant of two vectors. That is the addition of two vectors. Okay, and this is the angle at which the resultant will act, and this is the angle between A and B. Okay, so this is the mere actually extension of the triangular law. Okay, so in a similar way, you can also uh, make subtraction of this two vector. Okay, suppose you want to subtract A and B. So say this is A, okay, and this is B, and which is represented by the corresponding sides of parallelogram. Now, if you want to subtract B, so you just flip the direction of B and complete the parallelogram, and this is the diagonal which actually represent the subtraction of A and B, A minus of B. Now, if you want to have B minus of A, then you just extend A in reverse direction, as this is minus of B, this is minus of A, complete the parallelogram, and here this is the resultant. Okay, so this is actually B minus of A. So in this way, you can add and subtract these two vectors. So first of all, you need to master of that, because in some cases where relative, in case of relative motion or relative velocity, you need to add or subtract the different vectors. Okay. Now I will show another important factor here. Suppose you have more than one vector. Okay. Say A1 is a vector, A2 is a vector, and they are acting as a angle alpha 1 with respect to the positive x axis direction, and then again A3 and something like that, dot 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 of an, which is acting as alpha n. Okay, suppose you want to find out the resultant of these vectors. Okay, they are coplanar vectors, means they are acting in a plane. Okay, so what we'll do, we need to have two components. We actually resolve each vector into perpendicular axis. Okay, one is along x-axis and another component is along y-axis. Then we use the parallelogram law and try to find out the diagonal, and this diagonal actually represent the resultant of this all vectors. Okay, so how you can do that? Say this is a1, okay, and this is alpha 1, and this is x, and this is y. Now we resolve a1 along x-axis, so it will give a1 cos alpha 1, and similarly if you resolve a1 along y-axis, it will be like this, a1 sin alpha 1. Similarly for a2 also, so we can write down like this, and dot 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 an cos of alpha n. Similarly for y-axis also, this is an sine of alpha n. Now we have two vectors, ay and ax and ay. These are acting along x and y direction. So now we can add these two vectors, and you can easily add. So the resultant will be simple. Resultant is simply a of x square and a of y square. Okay. So uh, I think you will understand how to find the component of these vectors, and then you add these two vector. So in case of a large number of vectors acting in a single point, then you can also find out the resultant of these vectors. Now I just focus on multiplication. Okay. So multiplication of vector. So this is completely different from the very straightforward, but here it is not a straightforward because it vectors has magnitude as well as direction. Now there are two types of multiplication. One is called the scalar multiplication. What is scalar multiplication? Here, two vectors when multiply give you a scalar. Okay, this is a one type of product. Another is a vector multiplication. This type of multiplication, two vectors when multiplied together gives you the third vector. Okay, so I will discuss. I like to discuss it very deeply because it is very important. So what is scalar multiplication? It is a dot of b. Okay, suppose say this is a and this is b. They are acting at an angle theta. Then a dot b actually signifies the component of or projection of b in the direction of the a. Okay, so if it is x, then x by mod of b is simply cos theta. So x is mod of b cos theta. So the component of b along a is xa mod of a, obviously. So mod of a, mod of b, and cos of theta. Okay. So what is the scalar multiplication? It is simply mod of a, mod of b, and cos of theta. Okay. So this is the actually this is the projection of b over a. Now you see this component, this multiplication, scalar multiplication is maximum. This that means the projection of a b over a is maximum when theta equal to 0 degree, because cos theta is 0 equal to 1. So this become mod of a and mod of b, and it is minimum when theta is 90 degree. This becomes 0 because cos 90 is 0. Okay, so this is the scalar multiplication, and there is another important property here. Suppose say we have c, and a is written as like this: a1 I hat, a2 j hat, and a3 k hat. Okay, so and b is written as like simply like b1 I hat, b2 j hat, and b3 k hat. Now if you take dot product of it, I just take the first term here, so it will become a1 b1 I dot I. Okay, next is a2 b1 j dot I. Third is a3 b1, and this is k dot I. Similarly, we will get the six other terms. So total number of terms is 9, because 3 cross 3 is 9. Now I just concentrate on these three terms. Here I dot I. What is I dot I? According to the definition of the scalar product, I dot I is simply mod of I, mod of I, and cos of 0 degree, because I and I is acting along the same direction. So cos 0 is 1 and this modulus is also 1. So I dot I is always 1. But what about I dot j? So I dot j is mod of I and mod of j and cos of 90 degree. What is cos of 90 degree? Cos 90 is 0. So I dot j is 0 and I dot k is also 0 in similar manner. Okay. So this is the thing you need to understand. So if you try the component, then this term will also only remain. So this is only a1 b1 plus a2 b2 and term a3 b3 is only remaining. All other terms will cancel out or becomes 0. So in this way you can also find out the scalar product of two vectors. Okay, very simple. Now we will concentrate about the vector product of the two vectors. So suppose say C is a vector and C vector is A and B vector. When take the vector multiplication, it will give the another vector which is called C, and this C vector is always perpendicular to A and B. Okay, so A cross B actually written as mod of A, mod of B, and sine of theta. Okay, and also a n hat. N hat is a direction along the c vector. Is a unit vector, magnitude 1, but the direction is parallel to the vector c. So if we have two vector a and b, and if you take the cross multiplication of it, you will get another vector which is perpendicular to both a and b. That's the plane containing a and b. So a cross b, if you move from a cross b, you will get plus c, that is along this direction, and if you move from B to C, then you will get the minus C direction. Okay, so this is very important. It is actually follow the right-handed cross screw rule. Okay, so we have also the simpler thing like I cross I. What about I cross I? Mod of I, mod of I, and sine 0 is 0. So I cross I is 0. I cross J, I cross J is K, because I cross J is mod of I, mod of j, and sine of 90 degree. And we need to have another vector which is n, which is perpendicular to I and j. Perpendicular to I and j vector is only the k hat vector. So I cross j is k. So in a similar manner, you can also find out. But there is another way to find out it. Find out the cross product of these two vector. The physical meaning of a cross b is very simple. If you have two vectors, okay, one is A and another is B, and you just complete the parallelogram. This is B. Now, if it is X and if it is theta, now what is X? X by mod B is sine theta. X by mod B is simply sine theta. Okay, so what is X? X is simply mod of B sine of theta. Okay, now if you want to calculate the area of the parallelogram, then area is simply, I think, mod of A, the base into height. So this is A and this is mod B into sine theta. And area is a vector. Okay. So this is A cross of B, mod A cross of B. So actually the A cross B gives the area of the parallelogram. Okay. So there is another way to find out the cross product of the two vectors, and cross product of two vectors is generally given by very important rule, which is actually the matrix multiplication rule. Is if you have the component of A like ax, ay, az, so you can write down like this, and bx, by, bz, then just you expand the formula and you will get the cross product of A cross B. So this is I, and this is simply ay bz minus of az by minus j hat, simply ax simply ax bz minus of az bx, and last one is k hat, and in this case is ax by minus of by x. So in this way also you can also find out the a cross of b. So this is the way you can find out the dot product and cross product and addition and subtraction of two vectors. So this is the unique laws which govern the vectors, and you need to apply these methods and this rule in different problem involving force, electrostatic, magnetostatics. So please concentrate on those formula and try to understand what is the logic behind it and what is the inner meaning or physical meaning of this cross multiplication, addition, subtraction of vectors. So please subscribe me, and I will take the different problems on vectors and try to solve it to actually to have to give you the better understanding of how to use the vectors in different problems. So please subscribe me to grow my channel. Thank you for your patience.